Hello everyone, my name is Shen Liu and I am a PhD student at the Center for Data Science NYU. I'm very happy to present to you today our recent work on semantic segmentation for noisy annotations. Due to insufficient information, mistakes made by experts, subjective judgments, and many other reasons, noisy annotations are essentially everywhere in real-world datasets. And this problem has been extensively studied in classification, but much less in segmentation. For example, in medical imaging, annotation errors could happen because of mistakes made by experts or doctors. In weakly supervised semantic segmentation, a popular two-stage pipeline is often adopted. In such a pipeline, pixel-wise initial annotations are first generated by weak supervised signals. These initial annotations are often very noisy and are used to train a separate segmentation network in the second stage. Therefore, the second stage is indeed a segmentation problem with noisy annotations. Before diving into the methodology that we proposed to address training with annotation noises, we would like to introduce some vital observations during such kind of training. We observe that the network will first fit the clean pixel level labels during an early learning phase, as we can see in the first row of the figure below. Dog's body is missing in the annotations. However, in the early learning stage, the model can successfully predict out the body. However, after enough times of training, the model eventually memorizes the wrong annotations. We also observe that the previous phenomenon does not appear at the same time for different categories. Based on these observations, we propose ADELE, a method that corrects initial annotations using the model's output during the early learning stage. Now the question that arises naturally is how do we know when is the early learning stage if there are no ground truth annotations? During experiments, we realized that the early learning stage is about the same time as the learning speed of the model gets much slower. This makes a lot of sense, as overfitting to the wrong information is often difficult. Therefore, we start correcting labels using the model's outputs when the learning speed slows down. Following previous literature in semi-supervised learning, we added a consistency regularization across multiple input scales to encourage the model to produce predictions that are robust to arbitrary semantic preserving spatial perturbations. Together, ADELE achieves convincing results on noisy annotations in segmentation tasks. My collaborator, Kangning Liu, will now discuss the results.
As can be seen from this slide, our method outperforms the baseline for the majority of the classes. To evaluate the performance and provide some qualitative impression, we provide some figures on test set. Since our method is able to correct pseudo annotations during training and avoid overfitting to the noisy part, we achieve better generalization ability during inference. So in the first row, we see that our method is able to provide more complete segmentation of the cat. In the second row, we see that we provide more clear boundary for the person. In the third row, we see that our model is equipped with better ability to disentangle the foreground and background for the TV. It also applies to the fourth row, where we show that our model is able to recognize better for the bird and the water. It's worth mentioning that our methods can be easily plugged into any previous weakly supervised semantic segmentation models and improve the performance across different pseudo annotations generated by different weakly supervised semantic segmentation methods. For more information and the code, please visit our project website. Thank you.